Hi, Sean at Response Diagnostics again. I've got a Kawasaki ER6f here with a headlamp that doesn't work. It seems to be a fairly common problem, and we're going to investigate what's going on with it. The problem is due to a failed relay in this relay module here. I'm going to take it off and I'm going to show you how to replace this relay, and hopefully I don't know what the outcome will be yet, but I'm going to try and find out why the relays on these repetitively blow. This is the second, at least the second relay unit that this vehicle's had on it, and vehicle, it's a motorcycle, but whatever. So with the unit on the bench, we remove the 4 Phillips screws. Let's just take the cover off to show the board inside. Now the problem with these is you literally cannot do anything to this board until you actually have desoldered it from the housing. So let's just very quickly do that. And now we've got the board desoldered and we're going to take that out. I will give a little bit more of a tutorial on how to desolder these a little bit later on in the video. So on the other side here, we had that relay there, which, as you can see, I just removed from here. The relays seem to be quite difficult to obtain, and I've had to buy a couple from Poland. It took 2 weeks to get here. So we're going to put that in, put it all back together, and hopefully that'll be the headlamp working again. The problem is the layout of the wiring on the bike is, I think, very poor. This here is the relay that we're concerned with for the headlights. It's driven with a couple of diodes and fed from the alternator. Now, when you initially turn the lights on, you only get side lights. And then when you start the engine, the output of the alternator drives the relay. And then once the relay is turned on, it has a diode here that feeds back from its own output and keeps itself engaged. The problem, as I see it, is that I believe this signal is the prior to the regulator for the charging, and as a result we're going to have a much higher voltage here coming through from the alternator than your regular 12 volts or 14 in actual fact when charging, and that is then going to be overdriving the coil of the relay, and I believe is burning them out. Now I've got 2 units here, both with burnt coils on these relays, so either the relays are faulty or this layout is. So I'm hoping possibly to put a resistor in there. I may need to put a Zener diode in for a clamp or something like that to prevent these relays being overblown. Now, this unit is used on various Kawasaki motorcycles, so it may not just be a problem with this particular bike, but with the family of Kawasaki's that use this relay module. So here is the new relay. I've bent the leads flat on the dead one so I don't get muddled up. We're gonna put that in there, turn it over. People have different opinions of this. You can hold it in place with your finger if you want. You can bend the legs, or you can use a piece of sponge to hold it in place. I'm just going to flick it. No, I'm not, because it doesn't want to go. You see, just want to. I mean, normally I would hold this in with my finger, but I don't think I can do this while I'm on camera. Let me see what I can do here. Harder working whilst on camera than you actually think. we go. With a couple of them soldered, the relay isn't going to move at all, or very little. I do advocate using a fairly large tip on your iron when you can. Sometimes it seems a bit clumsy using a large tip, but it does give a much better distribution of the heat to your solder joint. I do recommend actually any work like this having some sort of vise or work holding. Trying to solder a board whilst poking it around on the bench really isn't the very best way to do it. So now I'm going to insert that board in there, make sure it's firmly in place. Before soldering them all, have a really good look and make sure the board is fully seated, because otherwise if you don't get it right, you're going to have to desolder it all and start all over again. I'll just quickly redo the rest of these joints now. As you can see, with a fairly large tip on the iron, we get good quick wetting of the joint, which means you're not hanging around for ages and you're not thermally shocking everything on the board. Just going to have a quick look. Got a couple that I would like just to put a little more solder on. If you can get it, I prefer multi-core brand solder. This is an American solder. It does work, but I really don't like it as much as good old multi-core. So here we are with the relay fitted and the board now back in the housing, and I think you can see from there, if you feel free to zoom in, but you probably wouldn't think that anybody's actually even been in with this board. I do tend to use brake cleaner to clean flux off. Well, it is an automotive workshop after all, and that and a soft brush, and then good blow dry with compressed air afterwards, and you've got a nice clean board ready to go back on the bike. Right, so now we've got the fuel tank refitted. Unfortunately, this relay module is actually under the tank, so to enable me to do testing, I'm going to have it just sort of stuck out the side there. I put some wire on the tank. The last thing I want is it flying on the floor, and I'm going to see now whether we actually get any headlamps. And yes, we now have headlamp working. What I'm going to do now is I'm going to set up some tests so that I can see exactly what's happening with that drive signal. Right, what I've done now is I've got the oscilloscope set up on the black wire, which is the signal to the coil of that relay. I'm going to start the engine up and we can see what happens. And that horrendous waveform, believe it or not, actually peaks in excess of 30 volts. But what it's also found is at the moment that this bike isn't charging. So it might be that we've got a charging fault that's causing these relays to blow up. So we're going to do some more testing. So having found my way down into where the rectifier regulator hides, which is just below the shock absorber here, let me pull the stuff out of the way, and we found what I was extremely suspicious of is a very corroded connector. In fact, one of the pins bottom right there's completely off of the rectifier regulator. Let's have a look at the connector. You know, sometimes they don't want to focus. Bear with me. There we go. You can see that has seen much better days. So it's looking like we're going to have a new rectifier regulator and probably a new connector if I can get one. So it's looking like if you're unlucky enough for your rectifier regulator to pack up, it's going to take your headlight relay with you as well, notwithstanding the fact that there may still be a further problem once I repair this. Rectifier regulator now fitted down in there. In the end I removed that entire foot peg bracket with the 3 bolts just to achieve some sort of access to be able to do anything with it. Right now, scope's back on it, and if I start the engine, to find out that we are achieving nearly 16 volts onto the input of that relay. I know it's only halfway, but I do think that's a bit strong, and I'm thinking possibly of putting a resistor in there just to cut down the load a little bit. When the engine is idling, the voltage is very high. When you actually bring the engine up to some speed, it drops right away. There is a meter on here that is saying 13.9 volts, so it's still holding it. But it's just a bit weird that when you rev it, the voltage goes down. I suspect it's probably the action of the regulator on it. Right, so I fitted a 68 ohm 1 watt resistor into the black with a silver or yellow marking on that wire on the center plug, and covered it in heat shrink for safekeeping. It's a higher value than I want. I calculated 36 ohms would have brought it down, but as long as it's sufficient here to pull the relay in, after that it actually performs no useful purpose apart from overloading the relay. Certainly seems to work at the moment. Going to finish putting it together and testing, and then probably do a close down on what I've actually done and why. Just to finish off now, I've replaced the relay in the relay module, which is hiding under the fuel tank. I've added a resistor there to save the relay if we get any, or help to save the relay if we get any further problems. And I have replaced the rectifier regulator there, which is just below the rear shock, which was the cause of the problem. So if it's been of any use to you, please do click a like on this. As they all say, it helps the YouTube algorithm. Following this is a longer clip of showing how I desoldered that board, and that's entirely up to you as to whether you watch that or not. So thank you, and I'll see you on the next one. At this point, I'm going to show you how my method of taking these boards out. You're going to need a few items. Obviously some of you will be very, very familiar with what I'm going to do and probably pick holes in it. Others, you know, you may just be setting out on soldering or whatever, or it may be something you don't often do. If you're really, really not confident, then give it to an expert rather than wreck it. But what you're going to need here, I've got obviously temperature controlled soldering iron. It's set at about 380 degrees. I'm going to use conventional tin lead solder. You'll need a desoldering gun. Okay, some people will argue with me to the end of the world that desolder braid is better. Use your own, whatever you fancy. You'll need some additional flux. I've got a couple of different ones here. I've never found one that I'm totally happy with, but you know, there's no flux on the board because it's been cleaned in production, so you're not going to desolder it very well unless you put loads and loads of solder on. So we're going to just run down all these joints here now, try and get some flux on them, like that, and let the solvent evaporate for a second or two. Freshly wiped clean soldering iron. I don't know how well this is going to show here, but what I do, you melt the joint out, let it get nice and hot, put the solder sucker, taking care to load it first, on top, and fire. And that one's gone quite well. So as you start to build heat in the board, life gets a bit easier because the solder melts out easier. Just going to work my way down these. I tend to work my way down and then see which ones free up and which ones don't. Depending, obviously, the more copper there is around, of, you know, PCB copper there is around the pin, then the harder it will be because you're trying to wet out something that's feverishly taking the heat away. And again, I can see that there's quite a few here are going to need to be redone. My usual technique, if the joint doesn't completely clear of solder, is to add some more solder and suck it again. And have a look at these. I'm old. I use magnifiers now so that I can see what I'm up to, because without it, I'm lost. And some of these might need a little more solder for the additional flux. Let's see. So there's one here that hasn't cleared. I'm simply going to do it again. Still not cleared. Sometimes it can take several attempts before you get the solder clear. This run is really being difficult. I bet there's a big slab of copper on the back of that. We just keep working our way down. I think the flux that I've applied probably isn't really doing its job very well. You don't want the iron too hot or you'll start to burn the board. But you don't want it too cold, otherwise it's not clearing the joints. So I might even turn the iron up just a little bit on this. I'm going to let this run full time. I'm probably not going to edit this down. So feel free to skip through if it doesn't interest you, but some people might just see
just how tricky it can be sometimes just to get the solder out. Being a plated, oh, that one's gone lovely. Being a plated through board, you've effectively got a tube of copper down the middle there. I do hope I'm not putting my head in the camera shot, because I'd hate to have to redo this all again. So, yeah, working with varying success on these. Some I can see that I really are. I'm going to have another pop at. If you've got maybe just one that won't clear, you can always heat it and lift the board off of it. But if you start using too much force, you're just going to wreck the board or break the pins, one or the other. That'll probably look really good on camera. I think I head-butted it. Let's have a look. Then once you're fairly certain that the joints are fairly clear of solder, there's nothing wrong then with getting a small pair of pliers and just gently tweaking the pin till it lets go. Once again, it's all about being a little bit sympathetic to it. Got a pin there. I'm just going to push that a bit more towards the middle. And now I think there. All right, I've moved the camera out. You probably haven't seen anything that I've done for the last few joints. Let's bring that back into place. So now a pair of pliers. We can just click them free. I've got quite a few here that are being quite reluctant. Make sure I can still see. Quickly take the screw out. And see how successful it's been. Nope, she's still holding on quite tightly. All right. So, it's going to go down. Those are free. Those two aren't. That one. So that works quite well. Sometimes with the soldering iron you can just bend the pin towards the middle of the hole and then it'll free it up. Same with that one. Sometimes you can just wiggle the lead over a bit. See if we've got it wanting to come away. Now this one is being much more difficult than the other one I did. That one's free, that one's free, that one's free. It just goes to show that sometimes they really can give you a hard time. Sometimes very gentle, a little bit of prising and then a touch with the iron. The other one, the first one I did, came off so much easier than this. It's quite unbelievable. But you can, if you look very carefully, you can see which ones are giving and which ones are on. There we go, we've got a few more gone there. There we go. And that is the board out. And yes, I've managed to pull a track here. This is always what the fear is here. I shouldn't have prized it. I knew I shouldn't, but I thought I could get away with it, and I was evidently wrong. So gonna have to do some repair work on that one. Otherwise, she's not going to work. But I'll cover that when I put it back together. So just the two. That would be very naughty. That one and that one. Now one of them hasn't got a topside track, so that doesn't matter too much. Let me see. This one here hasn't got a topside track, so I'm not going to worry about that. That will solder conventionally. This one here I've lifted, so what I will do is there's a little plate through there. I'll put a piece of wire through there and then put it on the pin the other side when I put it back together. In actual fact, I may be very lucky. Let me get a something fine piece of wire. Find something. It doesn't need to be a thick piece of wire when you're repairing a track like this, because in this instance here there's not a great deal of power going through it. But you can see if I put a strand of copper wire through there, which is right next door to that one that I've damaged, if I look it through the other side, we can actually just about see there that it actually goes back onto the same track. So that actually doesn't matter. I've got away with that. But if I hadn't, I would go through and then I would just wrap that piece of wire around the pin. It's only a current, relay current, so it's not going to give any trouble at all. So then what we're going to do when putting the board in, obviously make sure not to crush any components, and take the relay out. Let me see, once again the camera's moved. Keep clouting the thing. Put some more flux on these, like that. Yeah. Obviously that flux isn't being particularly successful. No, that one didn't go. Nor that one. Now on that one you can see that, or might see, that they have actually during assembly bent the leg slightly. Gently with the tip of the iron, bend it straight. Remember, we're discarding the relay, but we obviously want to save the board. And then she went. I think what I'm probably going to be doing with this one is gently wiggling it out whilst touching, rewarming the pins. Yeah, this one. Can't believe how difficult this board is being, to be honest. Actually turning the iron up a little bit now, got up to 420 degrees. Just observed the relay that actually has got, you might just see it, it's massively bulged. I've got a new rectifier regulator on order for this, and the new connector as well. When I change those, I'm just going to see if there's any other problem with the system, or if it is just simply that the rectifier's failed and just blown this up with it. I could really do with a camera with a longer focal length so I can get it out of my way. Unfortunately, trying to work around it really isn't making it the easiest. But then again, I'm not using special camera, I'm just using an iPhone. And hopefully that's good enough to give people the idea what I'm trying to do. At the moment I'm just wiggling it out one pin at a time, walking it out. This is taking a lot longer than I was hoping it was going to take, so I don't really want it to create an interminably long video, but at least if you do one and it's you struggle, you can go, well, that bloke struggled as well. So unfortunately the solder sucker's bunged up with solder, so I've got to quickly stop and clear that off. Get me back in. Rather than being a how-to, this is turning into a how not to. But hey ho. Right. They are getting quite clear, those holes now. Yep, here we are. And now, just a touch, you can just see the pins are walking out now. And that's the relay. Very burnt, very bulged relay is now out. Board appears to be fine on the underside, on the top side there. Get a new relay. Without a bulge. It is an NEC EQ1-11111S. There are equivalents around. These are 30 amp rated. I found an equivalent, but it's only 10 amp rated. I'm sure it would work, but you know, I'd prefer not to degrade the thing, so I've bought these genuine ones. So now find myself some solder. Put the iron back down. I'm making a right mess of it here. Right. The moment you've got a couple of joints, the relay's not going to go anywhere. Right, give it a quick look over. Now there is some sort of black marks around here. I am sort of wondering if someone's been in here before, but it could also be just the overheating from that overloaded relay. I'm just going to double check that track off camera here. No, that's going to be absolutely fine. So I'm just going to pop the board back in. Like that. And we could just pop that screw in just to keep the board down this time, which I forgot last time. Make sure that's firm. And time to get soldering. And it goes together so quickly. Right, off camera I'm going to, I will clean it, remove the flux and see what it looks like afterwards.